JAMB 2026 candidates, you all are welcome to today's calculation lecture. If you need any help, you need any material or short lesson notes that will help you quickly prepare for your JAMB UTME, or you need last minute preparation plan, please connect with me sharp. Write me sharp, make I help you pass. I don't want to make you fail. Write me sharp. No waste time. So this is the connect. All right. So the question we have in front of us under the topic specific latent heat of fusion. Okay. JAMB say make sure say you sabi solve this thing before you enter that examination hall. All right. So the question we have here is JAMB must repeat question 5. The question reads: calculate the mass of ice that would melt when 2 kg of copper is quickly transferred from boiling water to block of ice without heat loss. Specific heat capacity of copper equal to 400 joule per kilogram raised to power minus 1 per Kelvin raised to power minus 1. Latent heat of fusion of ice equal to 3.3 times 10 raised to power 5 joule kilogram raised to power minus 1. Okay, so first of all, we look at the options. What are they represented in? All options represented in kilograms. Okay, so our answer should be in kilogram and it should be in what? Fraction. Okay, so fraction and kilogram. All right, so what were we told to find? We were told to find, calculate the mass of ice that will melt. So we were told to find what? Mass of ice. So we put it here, giving mass ice. Okay, mass of ice equal to question mark. So this is what we are looking for, mass of ice. All right, since we are looking for mass of ice, what are we going to do next? Now we are going to read carefully for the second time to write out all the parameters given. But before we do that, we are going to write out the formula that we need to solve this particular question. All right, so since we are calculating mass of ice, we have to know that heat loss, HL, heat loss by copper or by the metal, heat loss by copper is Cu, heat loss by Cu is equal to heat gain. Remember that law that we used in solving a specific heat capacity, heat gain by ice. So the heat loss by copper is equal to the heat gain by ice. That's for melting, since we are talking about melting. Specific latent heat of fusion is defined as the amount of energy or the amount of heat required to take a substance from solid state to liquid state at melting point by 1 Kelvin. Remember to always represent the substance in kilogram. Okay, so 1 kilogram mass of a solid substance from solid to liquid at melting point by what? 1 Kelvin. All right, so that is the definition. So heat loss by copper is equal to heat gain by ice. As simple as that. That's the general formula when we are talking about specific heat capacity. Okay, specific latent heat of fusion, specific latent heat of vaporization. That's it, where we are comparing two substances or two bodies. All right, so we are going to write out the formula. Okay, therefore MC theta stands for temperature, this one heat capacity, specific heat capacity, this one mass, okay, is equal to, since we are talking about heat loss by copper, so specific heat capacity is equal to mass of ice. All right, mass of ice, then what? LF. What is LF? Latent heat of fusion. Okay, so this is what we are going to apply here. So before we apply this formula, let's write out what we were given, the parameters we were given to figure out if we have enough to use to apply this formula. So we were given, if you look at the question, we were given mass of copper. Okay, mass of copper equal to what? 2 kilogram. What else were we given? We were given specific heat capacity of copper. Okay, that's a C is equal to, they gave us what? 400 joule per kilogram raised to power 1 Kelvin raised to power 1. Okay, what was the temperature given? They said at melting point. So for a substance to melt, you need how many degrees Celsius? Is quickly transferred from boiling. So the substance boil, okay, to the block of ice without heat loss. Okay, so the substance boil. So boiling will be our theta 2 or temperature 2 equal to substances boil at what? Water boils at what? At 100 degrees Celsius. Okay, so our temperature 1 will now be what? Since the highest is 100 degrees Celsius where water boils, where does ice freeze? That's what is going to be our temperature 1. At what temperature does ice freeze? That's 0 degrees Celsius. Okay, so that's it. So what else were we giving? We are giving latent heat of fusion. Okay, so we're also giving latent heat of fusion. Most should come for under here. Okay, latent heat of fusion of ice. Okay, of ice equal to 3.3 times 10 raised to power 5 joule per kilogram raised to power minus 1. So let's now compare our formula with the parameters given. Okay, our formula here is MC theta, mass specific heat capacity and temperature, okay, and what? Mass of ice and latent heat. Do we have mass here? Look at it, we have mass. Do we have a mass of ice? That's what we are looking for. Do we have latent heat of fusion? Yes, latent heat of fusion of ice, this is it here. Do we have temperature, which is our theta? Yes, we have temperature, which is the theta. And this is going to be change in temperature. Theta 2 minus theta 1. So that's how we are going to solve it. So we now know that we have enough to solve. So we can go ahead to solve. So we substitute. Our mass M is what? M is what? 2 times C, specific heat capacity, which is what? 400. Times latent heat of fusion is what? 3.3 times 10 raised to power 5. 3.3 times 10 raised to power 5. Okay, so this is what we have. So what are we doing now? We are simplifying. Okay, so 2 times 400 will give us what? 800. Okay, there is something we didn't add here. We didn't add the temperature. Okay, temperature change. So let's calculate this and add our temperature change. Okay, so 2 times 400 will give us 800. But let's put everything together. Okay, 2 times 400, bracket open, our temperature. Theta 2 minus theta 1. May I just put 100 minus 0, bracket close, equal to M ice times 3.3 times 10 raised to power 5. So this is what we have. So if you do here, we are going to be left with 100 here. If we open this bracket, okay, then we put our times 400 times 2 equal to M ice, that's mass of ice, times what? 3.3 times 10 raised to power 5. Okay, 2 times 40 times 100 will give us what? It will give us 80,000. 80,000. Okay, is equal to mass of ice. Okay, mass of ice. Since we have only one standard form here, like I always advise you guys, anytime you have only one standard form, convert this standard form to figure so that make it no worry you. Okay, this shows that there are 5 zeros in this figure here. So we are going to now count the 0 together with the 3 after the point. So we are going to have 5 figures after the point. 5 figures after the point. So to convert this, we are going to have times 3. Okay, 33. Okay, so remember that the point was here. The point is supposed to be here. Okay, so we are going to from here and count to 5. Okay, from here and count to 5. We put 1 0, 1 2 3. Maybe we fair count. Maybe we know how many 0 will enter. 1 2 3 4 5. So 1 more 0. Okay, 1 more 0, and that's that for that. That's 4 0. So 33,000. So this is converting it to figure. Okay, 33,000. This standard form. Okay, so we are now going to have mass of ice 330,000. So what are we supposed to do then? We are going to do what? We divide both sides by the coefficient. So 80,000 equal to mass of ice 330,000. Okay, so we do what? We divide both sides by the coefficient of what is it? So we are now going to be left with mass of ice is equal to 80,000 over 330,000. Okay, so how are we going to simplify this? Okay, if you look at our options are represented in fractions, so we put the answer in fraction. 100 can go into 80,000. 100 into 80,000 will give us 8. 100 into 80,000 will give us 8 over 100 into 330,000 will give us 330. Okay, it's just like cancelling out like this, like this, like this. 1 1 2 2 3 3. Okay, 4 4. So we are left with, when we cancel that, we are left with M is equal to 8 over 33 kilogram. Okay, so you cancel this one out. So this is our final answer. Pick the correct option among these options and drop it in the comment section. See you in the next class.